Hi, everyone. Welcome back to another episode of Unscripted Coding. Today, I have a whole bunch of stuff running on my computer on the side, so I'm going to be doing my work on Code Sculptor. If you are not familiar with Code Sculptor, please do. Code Sculptor allows you to run Python 2 or Python 3 on basically any browser. It's really, really good if you just want to hash out, a simple algorithm. If you want to write something really simple, I do it a lot when I want to, say, put out a lot of strings. Let's say various dates, January 1st, January 2nd, January 3rd, or whatever, and manipulate it a little bit. It's just great because it's on a browser. If you have, a cheapo Android tablet, you don't have to worry about getting Visual Studio Code, all of that. But obviously, it's not great if you're trying to build Android apps. It's not great if you need to import a lot of things. In fact, I don't think you can do either of those. It's just there to run a handful of really quick Python commands to hash out something. So sometimes if I need to do some probability calculation where, I'm just not very good with it, I'll just pop it right into Code Sculptor, write code to kind of model it up. Long story short, if you use Python 2 or 3 and you sometimes like to do these things, you can save it, you can share it. It's just like a great tool. And so let's say you want to do a print statement, hello world. You have your console right here. Anyways, just looping back a second here, what our project is today is we're going to look at some form of code, and code as in encrypted messages, and maybe encrypt and decrypt it. Now, the whole idea here came from Computer File. I haven't watched this video because I think it would ruin a really, really fun project. But what I can gather from the title is he was trying to crack Enigma with code. And Enigma is, the machine, and I think over here, used by the Germans to send secret messages during World War II. And if you haven't seen, The Imitation Game or any kind of World War II documentaries, the British cracked the Enigma. Alan Turing cracked Enigma, and that was a huge boost for the war and is a huge reason why the Allies won the war. And it is a hugely complex piece of hardware, lots of cogs and wheels trying to move all of these letters back and forth. I don't know at all how it works, so this isn't going to happen in a 20-30 minute video. So they have clearly put in a lot of work. I may get to that, but I thought that was a great idea, and we can do something similar and scale it back. So I'm just going to look for common code. Common code. Enigma? No. Cipher device. Common ciphers, that's the word. All right. Vignere square. That has a strange name to it. Okay, ooh. These are not at all, these aren't ciphers. But okay. Let's try and look at, you know what? I think the Caesar shift is something really simple that we can both encrypt and decrypt in a real-time video. The Caesar Cipher is basically shifting the letters by a certain alphabet or a certain digit. So say you have A, B, C, D, E, F, G. That's your standard letter. And then you decide to shift it one over so that B is actually A, C is actually B. Everything's shifted over one. And you can type your code there. Let's see how we would approach this. My first thought is a alphabet dictionary. And I'm thinking we would give each one an integer first. Let's just stick with a three-letter alphabet first, so I don't do 26 of these to find out I did this wrong. And how would you approach it here? So you want to assign a number to each letter, and then you want to be able to reverse it back. So let's say we have okay. Let's go with the reverse alphabet dictionary then. And we will go A is 1, B is 2, C is 3. And the whole trick here is to basically be able to subtract or add numbers to reference the shift. And so the input is, and let's make this clear, the encrypted input is B, B, C, A. The key is how many it's being shifted. It's being shifted 1, and expected output is C. Okay, you know what? Let's put this here. So what we want to do is say A, B, C. That is our clean text message. That is what we want to send to somebody else. We want to scramble this. We put in a key, and since it's 1, it's being shifted left. So A shifted right. So A becomes B, B becomes C, C would probably be D, but because we're in a 3-letter alphabet, we'll say C becomes D. So the first thing we do is for letter in expected output, let's just print this out first. Print letter. See how that looks. Python for character and string. Okay, let's try this. I would have thought that a simple for loop would have worked, but I guess not. We should enumerate it first. Do we need to import anything? for enumerate. Okay, let's see. Right. Oh. Yeah, it does work. I turned letter into a string, so that was a dumb mistake. So for each letter, I want to find what the relevant number is. So we'll look at the reverse alphabet dictionary, and then we are going to find the index of the letter. So A will return 1, B will return 2, and C will return 3. So we will get correct number. Let's print this up as well. A1, B2, C3. Perfect. Just say what we're doing here. Encrypt. Input with a shift key. Encrypt. And we'll have the input, which is a string, and a key, which is a number. And we'll have to shift this down 1. Okay, for letter in input, for letter in input. So what I need to do is iterate through each one and get their numbers, which is what I've done here. And then we're going to add the fake number, which is going to be the correct number plus the key, which is a shift. So we're going to print fake number. Bad input. Go. We of course need to actually run the function, so let's go encrypt ABC, and the key is 3. So every number has been added, has 3 added, but we will need to use the modulo function. Modulo function length of alphabet dictionary. Oh, that is a bad shift. Let's go with 2. I think we should be 0 indexed because we are computer programmers. Okay, so what is modulo? Let's explain that first. This is a basic programming 101. Modulo is super useful because it lets you, it's the remainder. You remember when you divided numbers, let's say 8 divided by 3, you used to say 2 remainder 2. Modulo is that remainder number. It's saying get rid of it. It doesn't matter how many times you repeat it. I just want what's left over. And so in this case, let's say I shifted by 54. The numbers are added 54. We have 3 letters in our alphabet. It's supposed to go 1, 2, 3, 1, 2, 3, 1, 2, 3. And so the modulo is going to drop all of that repetition and give you that remainder. So 54 modulo 3 will give you 0 because 54 divided by 3, remainder 0. I don't think that was the clearest explanation, but do search it up. I think there's a lot of really good kind of explanations online, but it is super useful as a function. Okay, so let's run this. That's fine. 54 is divisible. Okay, so the next thing we have to do, and again, I'm picking really bad keys, is now print the fake. So fake letter is now the alphabet dictionary using the fake index now, or the fake number. And I will print fake letter. And so A becomes C, B becomes A, C becomes B. I don't think that's quite right. A becomes C, B, C, A, okay, C, A, B, okay. Yes, that is correct. So ABC becomes CAB because A shifts to C, it's down 2. B shifts to A, and then C shifts to B. It's 2 letters down, but because there's no alphabet after C, it comes back to the top. Okay, we have put equals, and then we will have output. Okay. So I am just that. Oh, so we now have a very simple encrypt. Now let's go with the decrypt feature. We have an input and then a key. So we'll take the we'll have the output again ready, and I think this is going to be very, very similar code. So for each letter, we're going to search up the reverse alphabet. So we're going to have to change our naming conventions here. For each letter, the fake, because you're decrypting, the first search you do is going to return the fake index. So we're going to search that. We get the fake number. Then the real number, correct number, is going to be the fake number minus the key now, and then we do the modulo function again. Then we have the correct letter. It's going to take in output equals the correct letter. Okay, let's take a look and see if that's fixed. So remember we said ABC encrypted with a key of 2 is cab. If we put cab in a decrypt function with the same key, in theory, we should get ABC back. So, print the output here. ABC. And that's basically a pretty simple way of doing this. So let's add a few more letters. D, 3, E is 4. Right. And we shifted. Oh, what happened here? Decrypt. Okay, so we've changed the size of our alphabet. So when we decrypt the CDE, it becomes ABC again. Of course, you can extend this, first of all, to all 26 letters in the alphabet. That's the obvious one. The other housekeeping one is you probably ignore special characters. So anything you can't find in the dictionary, you would just keep as is. I'm thinking punctuation, spaces, underscores, what have you. But I think one really interesting way to think about this is how you would solve it, how you would try and decrypt this without a key. And how I would think about it is I would just iterate through the keys, knowing that there are 26 alphabets, so basically 26 options. And what I would do is just take a dictionary, list of English words. GitHub. Yeah. GitHub has more than one of these where it's just a giant list of words. This one is, let's see. They just have a giant list of words, English words, basically a giant dictionary. And what I would do is decrypt, go through each key and see if just count how many words match the English dictionary. And so you might have X, Y, Z, B, D or something, and that would be thrown out. But as soon as you see something with abdomen, you know that, okay, that's a candidate for a correct answer. And so you don't need AI, you don't need real eyes to narrow down and get rid of all of the fluff. And that's without a key. You can just cipher through all of them. Basically search a dictionary, see if there are the right numbers. But this was really fun. It's just walking through, figuring out how you would solve this. And albeit Caesar Cipher is probably like the easiest possible code we can think of. When I have a bit more time and when I'm not just doing this on a browser, who knows? I may try and tackle the Enigma, although that is very, very ambitious. But I think there were definitely more ciphers for me to kind of practice basic algorithms, basic problem solving. So this was a lot of fun. Let me know if you enjoyed this. As I'm doing this, I'm realizing it might even be fun to do some of those Google interview puzzles. And again, you need to understand, I am not a programmer. So yes, if I'm talking through this quite slowly and I'm solving this very slowly, you'll have to forgive me. I would not pass a Google interview. But there are all of these kind of algorithms and problems to solve that I think would be a lot of fun to add to the channel. So thanks for watching. Please do leave a comment. And if you enjoyed this video, please leave a comment, like, subscribe. Do whatever you can to help the channel, because every one of those counts a lot, and I could always use more support. So thanks for watching. See you guys next time.